right, so last example here, we've got cotangent beta plus cosecant of beta times 1 minus cosine of beta is equal to sine of beta. So when you have an example like this with the left side, it's pretty clear that it wants you to multiply through, right? So from here, we're going to go and multiply and then see what, and then we can switch to sine and cosine and then just kind of see what happens. So we've got tangent of beta times 1, or sorry, cotangent of beta, times a negative cosine. And then we're going to distribute the cosecant. So it's plus cosecant of beta. Cosecant times negative cosine is a negative cosecant beta cosine of beta. Okay, so obviously we're hoping to get some things to cancel out, right? Because we're trying to get it down to sine. So I'm going to go ahead and change these all in terms of sine and cosine and see what we can get from here. So cotan, it's cosine over sine. Cotan, that's going to be cosine of beta over sine times cosine of beta. Cosecant, that's going to be 1 over sine of beta. And cosecant of beta times cosine of beta, that's cosine of beta over sine of beta. Okay. So a couple things that I notice here when I do that. Here I've got a positive cosine of beta, sine of beta, and a negative cosine of beta, sine of beta. So those are going to cancel, right? Then from here, what I have left is we have a negative cosine squared of beta over sine of beta plus 1 over sine of beta, right? So we have two terms left that have a common denominator, right? So I'm going to add those together. I'm going to go ahead and flip them around. Instead of saying negative cosine squared of beta plus 1, I'm going to say 1 minus cosine squared, just because that's what we're kind of used to working with. Okay, and keep in mind, we're trying to get this to equal sine of beta, right? So sine of beta, I need to try to cancel out my fraction. Sorry, that's not sine squared, it's just sine. We're trying to cancel out that denominator, right? And from here, pretty clear to me that 1 minus cosine squared, using those Pythagorean identities, is sine squared. So we make that sine squared, the denominator sine. Okay, one of those is going to cancel, and so we're left with sine of beta. Right. So we verified the identity.